welcome to Professor Shams's inaugural lecture. Really glad to have you all here, both those in the room and online. I just want to make a couple of announcements about the department. So I'm Professor Joanna Faure Walker. I'm head of department here at the Department of Risk and Disaster Reduction. This is part of our monthly event series, open to all. We have some online events, some in-person events, some in the evening, some during the day. And we like to talk about all subjects related to risk and disaster reduction. Coming up on the 5th of June, we have our alumni breakfast. So some of you will have received invitations to that, and we hope you can join us. And then on the 1st of July, we have our annual conference, Where is the Human in Humanitarianism? So again, that's open to all. So we hope to see as many of you there as possible. It is absolutely wonderful to be introducing Shams today in his inaugural lecture. It is quite emotional as well. So Shams was a postdoc at the IRDR then, when we were still an institute, before he became a department. And he was one of the initial postdocs as part of the department who started the whole things off. So going from that, and he had already done his PhD at UCL as well in geography. It's lovely to see people from his PhD here. And then he left UCL for just a little bit, not for very long. We got him back. He came back to be an associate professor and then now professor. And it is really wonderful. And as I say, I think everyone here is so happy you're here. I'm going to let Shams talk about his work because actually he can talk about his work better than I can. But to say that it's had impact and to say that it's right at the heart of what our department is all about is an understatement. People who know me know I don't like using superlatives. I don't like the word very. I don't like the word most and all these things. I try and cross them out every time people use them in documents. But it really is something we can say about Shams's work, how much he has done to help people, his collaborations, his work, particularly on arsenic, water poisoning, groundwater, is absolutely amazing. And you're going to hear all about it. But this is work that is such fantastic science, including featuring on the front page of Science, but also really does save lives. So it's really wonderful to hear about that. So I'm not going to go on for too long because Shams has told me that he has a lot to say. So said, Joey, please be quick. So I have plenty of time, but really wanted to say and get us all together to actually give Shams a massive round of applause for becoming professor and for doing so much for the department, for UCL, and actually for everybody and the people he's helped.
Thank you, Joey, for the kind introduction. Thank you all for being here this evening for my inaugural lecture. I really appreciate your presence. Nearly 18 years ago, I came to UCL to begin my PhD training in the geography department. Did I ever think of giving my inaugural lecture in this very institution one day? I did not. But I certainly hoped to become a leading researcher in the field of water security. So when last year I was promoted to Professor of Water Crisis and Risk Reduction, I became curious. I wanted to know whether I was the first professor of Bangladeshi origin here at UCL. So with a bit of help from Nidhi, I contacted UCL HR, and they told me I was the 5th. Was I disappointed? A little bit. But you know what? I'm the first professor of Bangladeshi heritage in the Faculty of Mathematical and Physical Sciences. Thank you. And that's what I'm proud of. And at a time when I think diversity is being challenged in different parts of the world, I feel really proud to be at an institution that values diversity. And I'm very grateful to be in a department that actively promotes equality, diversity, and inclusion. And that's what keeps me going. So I'm really proud to be here in this institution. So tonight, I would like to dedicate my inaugural lecture to my parents. My dad sadly passed away so 15 years ago, when I was finishing my PhD here at UCL. My mom prays for me every single day, and she's incredibly proud of what I have done, what I have achieved. So I'm very grateful to my family. Yeah, is that? Okay, I think this is my Oscar moment. So I will be talking to you about my research, my publications, and impacts. But before I get there, I would like to take a moment, a good moment, to say thank you to those who helped me in this long academic journey. And it starts with you, my lovely colleagues from the Department of Risk and Disaster Reduction. Thank you all for your support all these years. It means a lot to me. I am deeply grateful and thankful to Professor Kazimuddin Ahmed from Department of Geology, University of Dhaka, for his mentorship, collaboration, and support for nearly 30 years or so. Professor Ahmed introduced me into the world of research when I was recruited as a field hydrogeologist to work with a group of scientists from Columbia University in the US, along with other researchers from Bangladesh and particularly Dhaka University. And that was really the beginning. I knew that I wanted to become a researcher. So I thank Professor Ahmed for this opportunity. You can also see in the picture my family, my wife, who happens to be a student of Professor Kazimuddin Ahmed. And our son is here in the audience. So I thank you for your support, your love, and also putting up with me. As you know that I spend more time on my computers than with you too. So thank you for your support. I'm deeply thankful and grateful to the two kind-hearted individuals who supervised my PhD here at UCL between 2007 and 2011. We have Professor Richard Taylor from Geography in the audience. Thank you, Richard, for coming. And Professor Richard Chandler from UCL Statistical Science, who couldn't be here for another commitment tonight, but he sends me his congratulations and well wishes for this inaugural lecture. I'm really thankful for the brilliant supervision of the PhD that I did here. And the commitment to research integrity and always encouraging me to think outside the box. And this PhD gave me a very strong foundation on which I built my academic career. So thank you very much for brilliant supervision. In 2012, I ended my 15-year-long university studentship. I spent an awful amount of time in universities in different parts of the world, Bangladesh to Australia to US, and finally I ended up being here at UCL. And I started my first academic career as a postdoctoral research associate with Professor William Burgess from UCL Earth Sciences, while I was based at the Institute for Risk and Disaster Reduction, as Joey said, which has now become the Department of Risk and Disaster Reduction. I had a fantastic time with Willie, working with him on a very exciting project on security of deep groundwater in Bangladesh. What I really enjoyed about the project is the opportunity to work with the community of stakeholders and policymakers. A very rare opportunity, I think, for many academics. So I really enjoyed that opportunity, and particularly really taught me how to do it effectively. So that was really a good lesson, a lifelong lesson that really helped me going forward. So thank you really for being here tonight. Now something more personal. And I believe that everyone experiences some kind of turning point in their life, either to an opportunity or a challenge. For me, I thought it was a bit of both that changed my life, I would say, now that I reflect, going back. And for me, that moment came on a sunny day like this in Regent's Park in July 2019. This was my leaving do, a farewell. I was leaving UCL to start my academic career as a lecturer in physical geography at the University of Sussex. So this was a bittersweet moment for me. I was very sad because I was leaving after 12 years being here at UCL. But I was also very happy that so many of you came to say farewell. So the next 2 years, when I was at University of Sussex, I spent about 2 years there. It was quite a difficult time for me because I stepped way outside of my comfort zone. I was so comfortable here at UCL, 12 years. So when I was at Sussex, of course, I was supported by colleagues from the University of Sussex. I developed my teaching career. I developed and delivered a brand new module, which was one of the most popular modules in the whole School of Global Studies. And that opportunity changed me into someone more confident and more resilient, if I can use the word. So my separation from UCL didn't last very long, about 2 years. I came back to UCL as an associate professor in 2021. And I led the BSc program in Global Humanitarian Studies. So I'd like to give special thanks to Professor Peter Salmons for supporting me and also challenging me at times. And he trusted me with the program leadership role of our brand new BSc program back then in 2021. And that really helped me grow as an academic leader. So thanks to Peter for that opportunity. Now, frankly, I don't think I would be here standing in front of you giving my inaugural lecture without the very success of our BSc program in Global Humanitarian Studies and the incredible support, respect, and love that I received from my students. So I really like to thank my students who graduated last year on this program and who are still studying with us today. So thank you very much for all the support. Let me now take you to a primary school in Bangladesh. It is not just any primary school. This is the very primary school where I studied in the 80s. I was invited by a college friend who is now the science teacher in that primary school. So I went there, spent time talking to a class of year 5 students. They were not shy at all, as you can see from the pictures. They were very interested to know about my education, my background, my academic life. And some of them wanted to do a PhD here at UCL. So that was quite a moment, really inspiring. So when I was giving a mini lecture on water security, I noticed a painting on the wall in the back of the class. Let me zoom in that for you. This drawing of global water cycle, this is in Bengali version. They also have English version. Was something that caught my attention. And I immediately noticed something is not right in this global water cycle. I asked the students, they struggled to answer when I asked what was missing in the global hydrological cycle illustration. Can you spot what is missing in this diagram? Anyone? Yes, please. Groundwater. Shaluka? People. Great. Yes. Groundwater is missing. And of course, people are also missing. But let me focus on groundwater for a moment, because this is the subject I'm going to talk to you about for the rest of the lecture. So groundwater is missing from this water cycle illustration. Now, one can say, well, what's the big deal? You know, it's just a simple omission. For me, it's a big deal. I don't think it's right, because in a simple way, it is acting as a process of marginalizing groundwater, because a resource that is out of sight stays out of mind. Because groundwater is the largest store of fresh water on Earth, as it represents 30% of the planet's 2.5% fresh water. If you exclude the fresh water that is locked away in the ice caps and glaciers, groundwater makes up of 99% of all accessible liquid fresh water on Earth. So it is a big deal. Not only that, groundwater is also the slowest in the circulation. It takes awful amount of time for groundwater, the water particles, to move through the aquifer, to resurface again and come back up into the global water cycle. Depending on the depth, the geology, the location, it can take decades. It can take centuries, millennia, and in some cases, it can take 1,000,000 years for that cycle to complete. So it is these properties, the largest store of fresh water on Earth, the longest residence times, general purity, not being able to sense what is happening on the surface right away, and under some special circumstances, the ability to capture more fresh water from rainfall and surface water. All of these properties make groundwater more climate resilient water supply. And that has been the focus of my research in the recent years. Talking about research, I asked ChatGPT, can you create a word cloud? ChatGPT said, how do I do it? So I gave all the titles of my publications, and this is what it came up with. So this is the research landscape that my research represents. Now, if I were to summarize my research landscape, it would come down to these 3 key research domains: making groundwater visible, tackling health and food insecurity, and digital data for sustainable water features. I'd like to talk to you about the first point, making groundwater visible. To make groundwater visible, in 2023, we published a global review that was published in Nature Reviews Earth and Environment, which has been already cited over 600 times. So in a way, I think we can say we have been successful to make groundwater visible, at least it is getting attention. What is interesting is that in this paper, we positioned groundwater as a key resource to achieve water security, to achieve resilient water future. So groundwater is the center of it. As you can see, nations can become economically secure, financially secure, if they have access to more fresh water. So this diagram here, the scatter plot, shows that countries' GDP is very closely associated with annual freshwater withdrawal. And in many cases, water security basically means groundwater security. And this map here shows the top 10 countries in the world in terms of groundwater use. And Bangladesh is the 6th largest groundwater user in the world. Much of the groundwater in Bangladesh is used to produce crops, primarily rice crops, to feed 165, 170 million people. And many people in Bangladesh do love their rice. I remember when I was growing up, I used to have rice 3 times a day. And many people still do it. I don't do it for health reasons, but I still love my rice. Groundwater has transformed Bangladesh's economic development over the past few decades. It has made the country almost self-sufficient in food grains. And as you can see from the map, groundwater is widely used. So I was curious. I wanted to know how much groundwater is used in Bangladesh. So I estimated groundwater use using publicly available information. And I came up with a figure, 32 cubic kilometers of groundwater. Sounds like a lot. To put that into perspective, the city of London uses 2.6 billion liters of water every day. And that amounts to about a cubic kilometer of fresh water every year. So with that water, 1 year of groundwater supply in Bangladesh can support the city of London for about 32 years. That is how much water is used in Bangladesh. And what that water has done, it has made Bangladesh nearly self-sufficient. It has transformed the country from a famine-prone land into a food-secure nation over the last 50 years since its independence. And you can clearly see from the graph on the bottom right-hand side, where the increase in food production is mirroring the increase in number of irrigation wells in Bangladesh. The other achievement is that it has cut down the mortality rate from diarrheal diseases by half by switching from polluted surface water to groundwater. Now, it's not all rosy story. Groundwater has its own challenges. One challenge is associated with groundwater quality, and that is arsenic and salinity that Joey mentioned. And groundwater depletion is about groundwater quantity. So one is quality-related issues, and the other one is quantity-related issues. And both of these have been the core research area of my research over the last 2 decades. So I'm going to, whatever time I have, I'm going to demonstrate what research I have done to address, to better understand these problems, and how my research has contributed to policies and also government investments in infrastructure development in the last few years or a decade. So let's start with arsenic. Last year, I co-authored another review article, also published in Nature Reviews Earth and Environment, where we mapped at the global scale occurrence of arsenic in groundwater. And we reported 300 million people across the whole world in about 50 countries where arsenic in groundwater has been reported, are now exposed to very high concentration of arsenic. What does arsenic do to human bodies? Well, arsenic is known as the king of all poisons. It is a well-known carcinogen that can cause cancer. And in human bodies, if you are exposed to high arsenic concentration through your drinking water and food, your body, different organs will start to accumulate arsenic. And over time, it would lead to organ failure, sometimes cancer, and ultimately death. It's a slow poison that can take years of human exposure to drinking water. It's not like diarrhea. If you have a sip, you will not die. It will take maybe 10 years in some cases. So it's the slow poison. In Bangladesh, arsenic was discovered in groundwater in 1993. You might be wondering, why? What is Shams is talking about? This is a very old problem. It must have been eradicated by now. The answer is no. In Bangladesh, still 20 million people plus are still exposed to very high concentration of arsenic in their drinking water, as well as in the food. When the problem is not everywhere, some parts of the country, arsenic is highly concentrated in groundwater. As you can see from the map here, the areas that are colored, that are marked in yellow, orange, and red are the areas where arsenic concentrations are very high. When I say very high, they are higher than the WHO standard, World Health Organization standard of 10 micrograms per liter. And in Bangladesh, it is 50 micrograms per liter. So you can clearly see that the areas in the south central and southwestern part are the areas where arsenic concentration is very, very high. Oh. Suddenly worked. Okay, I go back. Oh, I'm giving away. Okay, so one step down. Yes, so here, if you look at the vertical distribution of groundwater arsenic, it looks like that. So arsenic concentration tends to peak at around 30 meters below ground level. So it's a very, we're talking about arsenic concentration and contamination of shallow groundwater aquifers, shallow aquifers. So here, it creates a kind of bell-shaped profile. There are a number of hypotheses in the early days when arsenic was discovered in 1993. Soon after, researchers tried to explain the bell-shaped profile. And there are a number of hypotheses proposed to explain the bell-shaped profile. One of them here is showing that irrigation, groundwater-fed irrigation is responsible because it brings organic carbon that feeds bacteria, and the bacteria then release arsenic from minerals, and it gives a bell-shaped profile like this one. And the other hypothesis was suggesting, no, actually irrigation, because of irrigation, groundwater is replenished and it flushes the excess arsenic from the system. And my early research contributed to this debate, even resolved this debate, because I used sophisticated advanced statistical model to show that indeed the arsenic flushing hypothesis is much more plausible according to the statistical model. So the conclusions were that actually groundwater-fed irrigation is not responsible for arsenic mobilization of the shallow groundwater systems in Bangladesh. As you know, groundwater is so important for food security. So that finding, I believe, helped put this debate into the conclusion that yes, arsenic groundwater-fed irrigation indeed was not responsible for arsenic mobilization in Bangladesh. Now, it's a very old problem, as I said. Now, there are other water quality related issues in Bangladesh. A couple of my PhD students are currently working on salinity problem in groundwater in Bangladesh. There are other areas of Bangladesh that are experiencing groundwater depletion because of intensive groundwater abstractions. Now, also because it's an old problem, government focus has shifted. Public awareness has worn off over time. And investment, particularly international development aids and funding from donors, are often these days earmarked as climate adaptation. And it's very difficult to link arsenic to be a problem that is linked to climate change. So how do we bring back the focus again for arsenic into the limelight? So I led a study where I thought we should look at these problems as an interconnected issue. And being here in the Department of Risk and Disaster Reduction, I put a hat as a risk expert. And I thought, wouldn't it be nice to combine all of these multiple different hazards through a multiple hazard lens and come up with a composite groundwater hazard map like this one. So I published that work in Exposure and Health Journal, and later on it was picked up by the World Bank, and they also published this as a working policy report. And my long-term colleague in the World Bank, Dr. George Joseph, has been supporting my work on groundwater hazard and risks to public health and food security for some time. And my work is also quite well known within the World Bank. And George very strongly believes that my research on multi-hazard groundwater risk to health and food security has really influenced the regional policy discussion in beyond Bangladesh. So I now like to take you to the other research domain, which is about water quantity. And I would like to present you some of the work that I did to highlight groundwater storage dynamics and groundwater depletion. So starting again with the global perspective. So this is the paper that I co-authored, published in Nature, where we studied over 100 million data points from over 1.2 million wells from around 40 countries around the world. This work took quite some time, and the lead author, Scott Jaseko, of course, did a fantastic job leading this team. It took nearly 2 years to get this published. What we did in this paper is we looked at trends in groundwater levels, and we reported that groundwater levels in different parts of the world have been declining at an accelerated rate. And we also reported that there are some curious findings, some interesting areas where we have seen recovery of groundwater storage. And Bangladesh stands out to be one of those areas where we not only have depletion, we also have an opportunity to use groundwater more sustainably. And I'll get to that in a second. So since my PhD work, I did a number of studies looking at groundwater dynamics in Bangladesh. In the interest of time, I will only focus on the science paper that was published in 2022. But before I get there, I just want to present and show you that my decade-long research on groundwater dynamics, and particularly characterization of trend, contributed to the policy documents in Bangladesh and also led to some investment in monitoring infrastructure. For instance, Bangladesh government has adopted their flagship policy report called the Bangladesh Delta Plan 2100 to achieve safe, climate resilient, prosperous delta. And they call it a gift for the future generations by the present generations. And they identified some goals, particularly goal number 2, which is about enhancing water security, is very relevant to my research. And the baseline report, the volume on groundwater, heavily cited my work on groundwater dynamics and groundwater depletions that I've been doing over the last decade or so. Not only that, it was quite humbling to hear from the former director, Dr. Anwar Zahid, Groundwater Hydrology Circle of Bangladesh Water Development Board, who served the board for about 29 years before retiring last year, sent this statement, sent this quote, where he said that my research has been instrumental in supporting the Bangladesh Water Development Board, which is a key government agency in charge of monitoring and managing Bangladesh's water resources, not only groundwater, water resources in general. And then also it was good to see that my work informed government investment on groundwater infrastructure, which is, as a researcher, quite exciting thing to hear. So I'm quite happy with that. Now, the paper that really brought groundwater into the limelight is this. The Bengal Water Machine, quantified groundwater storage, quantified freshwater in Bangladesh. So that was featured on the cover page of Science issue of September 2022. And that paper was very widely covered in social media, print media. I was interviewed a few times by TV channels. And a daily Bangladeshi English newspaper, the Business Standard, did a whole feature article calling it the miracle in the Delta. And that brought me a little bit of fame. So I was very happy with that. Now, before I present this paper very briefly, I just wanted to acknowledge and pay tribute to the very people who have been collecting groundwater level data sets in Bangladesh for decades. For the science paper, I used about 1 million data points from 465 monitoring boreholes, like this one, from all around the country. And in the picture, you can see Mr. Nirendranath Shaha has been an observer since 1990. Mr. Abdul Sattar has been an observer since 1996. And they have been measuring groundwater levels every single week for the last 30, 40 years. So, I mean, it would be wrong if I don't acknowledge the time, the effort, the dedication that these observers put into developing the national groundwater level database. And these are not 1 or 2 people. There are over 1,200 monitoring stations in Bangladesh that Bangladesh Water Development Board manages. So there are 1,200 plus observers, and each of them monitor every week groundwater level in their boreholes. And I just found out that they receive less than £2 a month, not as a salary, but as an honorarium, because they're doing some kind of community service. So it is not their paid job. But again, it's very ironic to actually think that they only receive less than £2 a month for this great job that they have been doing over decades. And I was able to use, as I said, about 1 million data points from 465 boreholes to do the science paper. Very quickly, so here you can see one groundwater level time series record that shows ups and downs. So it goes up during the monsoon season, primarily because of groundwater recharge or replenishment, and it goes down in the dry season for rice irrigation. Now, under some special circumstances, these oscillations in groundwater levels can happen because of changes in pressure on the surface, because of surface water appearance and disappearance, depending on the seasons. But for our science analysis, we assumed that the changes happening, the oscillations in groundwater levels, were basically reflecting groundwater replenishment in the wet season and groundwater discharge in the dry season. You can see it's a very simple thing that everyone does. Whenever you have a time series, you will do a trend analysis. You would like to know which direction the variable is heading to. So here, if you fit a trend line through the wet season water level, dry season water level, and the mean water level, all of these indicators will tell that in this side, groundwater level has been going down. Therefore, it is perhaps unsustainable. Do you agree with that? In the science paper, we actually reported quite the opposite. We say, despite declining groundwater levels in this particular aquifer represented by borehole MY050, groundwater storage, the long-term groundwater storage has increased. And we quantified that increase. Let me tell you what and how. Imagine the aquifer that is represented by MY050 borehole is your bank account. Your wet season recharge is your income, and your dry season water levels is your spending. In the past, the account had a capacity, limited capacity. It would fill up during the wet season because of recharge, and it would empty during the dry season because of discharge, because the account had very limited capacity. Now, as you start pumping, as you start to withdraw more water from the aquifer to produce crops in the dry season, and that's what the farmers in Bangladesh did, you see that the dry season water levels start to decline. But here is the twist. By doing that, you are actually removing the account ceiling. Now the account is now able to receive more deposit in the wet season because of increased recharge. So despite all the indicators suggesting that the groundwater level is going down, you are actually getting more interest payments because you have now expanded your deposits. Does it make sense? And that's what we calculated. We estimated using a very standard hydrogeological formula called the water table fluctuation method. And we showed that groundwater recharge in this particular area increased from the pre-irrigation period, 88 millimeters, to now 185 millimeters in the recent fully developed irrigation period. And we calculated the cumulative freshwater capture over the long period of time was about 3,000 plus millimeters over a 30-year period. And we did that not only in one site, we did that at 465 locations, and ultimately came up with a map that shows a volumetric storage gain in Bangladesh at the national scale, and that is 75 to 90 cubic kilometer of freshwater capture by the 16 million farmers pumping every year a bit more water to produce more crops, unintentionally, unknowingly, but in a concerted way. And we call this the Bengal water machine, an invisible water machine created by the 16 million farmers in Bangladesh that have helped Bangladesh to become not only self-sufficient in food production, but also perhaps helped with flood mitigation, something that is still an open question for further research. And this study has the potential to contribute to the Bangladesh Delta Plan 2100. For that, I'm already engaging with the key stakeholders. I've already made contacts with the current director of Bangladesh Hydrological, Groundwater Hydrology Circle, Bangladesh Water Development Board, who is very supportive of my work, and he's willing to work with me to realize the potential of the discovery of Bengal water machine. We organized some workshops in Bangladesh and engaged with other stakeholders. For instance, Bangladesh Agricultural Development Corporation. The chief engineer was quite delighted to see me last year, and he said, we definitely need to work with you because we need to manage our irrigation water. So I'm looking forward to working with the key stakeholders to take this forward and realize the full potential of this invisible water machine. Now, finally, where I'm going with all of this is that being in the Department of Risk and Disaster Reduction, I always think about risk. Okay, how can my research could be interdisciplinary? How can I include more research elements, risk elements to it? So I actually think that it is time for us to promote the recognition of hydrogeological hazards into the disaster risk reduction frameworks, both nationally and internationally. And I'm working on it now, and I need your support and help to one day to get this hydrogeological hazard as a new category included in the disaster risk reduction framework. Now, to sum up, I think I have managed to convince that groundwater matters when it comes to water security. I strongly believe that the discovery of my research, particularly the Bengal water machine, can build a better and sustainable Bangladesh. And I like to leave the legacy through my work by promoting the recognition of hydrogeological hazards into the disaster risk reduction framework nationally and internationally. And I cannot do that without you. And I feel like my journey has just begun. So thank you all very much for listening.